Okay, let's see where we've been and where we're going. Remember that you want to go through something the first time. Don't expect to get it, so you preview. Don't go slowly. You kind of get a sense. And then you grind it out, you work it, you do some homework, you write some cards, you think about it, you ask questions, check whatever, reread it, and then you review it to keep it in mind. So let's do a little bit of review in this quick little video. Remember what we're doing in chapter 1. Chapter 0, we did all this crazy stuff. In chapter 1, we're going to naked eyes and what you can see. We talked about stars and those 5 things that we can see about stars and 5 things that we can't see, but we can wonder about, but we'd have to wonder about it for quite a long time. We're going to cheat a little bit today. So we're going to come back and review some of that, these dots of light, these so-called fixed stars that do move, but they stay together, right? Then I'm going to mention streakers in about 30 seconds after this in the next video, and we'll talk about planets, wandering dots, and we'll go on through this stuff. So let's talk about this, and let's remember a little bit of chapter 0, right? We did chapter 0. What if we took Earth? It's a globe, nice old globe, I like it. And we shrunk it down, shrunk Earth down to this size, and we shrunk everything else down proportionally. If we shrunk it down even more? Heck, what if we took Earth and we shrunk it down to a grain of sand? So we live on this grain of sand. You can imagine how small we would be. And we've got Earth as a grain of sand. How big would Sun be, or Moon? It's really hard to tell to look up, right? It looks like Earth is bigger than the Sun. I mean, look up, there's a little ball up there, but you know it's big. If you shrunk Earth down to a grain of sand, Sun would be this big, a softball. Moon would be 1/4 of that grain of sand going right around it. And we'll talk about the distance later. But it'd be like 10 long steps or 20 regular steps away. Earth would be from Sun. But we're ancient shepherds. We don't know this sort of thing, right? So here we are. 1 grain of sand, along with some other kind of grains of sand, orbiting a star. And that's called our solar system. And that whole thing, on average, Earth to Sun, we call that a what? An AU, an astronomical unit, about 93 million miles approximately, right? So from our Sun. On average, Pluto is 40 times farther away from Sun, 40 AU. Could be as close as 30, as far as 50, but about that. And that's our solar system, and then you got some comets out there. So that's stuff going around our soul, our Sun. And that solar system is about halfway out from the center of our Milky Way. The whole thing would be much smaller than a grain of sand. It would be smaller than a pinpoint. All Sun, Earth, all planets, Pluto, comets, so tiny in our galaxy. Our planet Earth, part of a solar system, our solar system going around Sun, part of our Milky Way galaxy, which is a barred spiral. This is incorrect, which I like, because as we discover, we get to say, oh, we were wrong, that's okay. And our galaxy, one of many galaxies, zoom it out. Our planet, part of a solar system around our one sun. Our one star, halfway out in our galaxy. Our galaxy, Andromeda Galaxy, and a bunch of other galaxies, maybe about 50, in our little cluster or group of galaxies. A part of a supercluster or supergroup of galaxies. Supercluster is a group of clusters of galaxies. And then the entire universe having a bunch of superclusters of galaxies. In all, about 100 billion galaxies, each with about 100 billion stars. Small one, 1 billion star, maybe 1/10 of a billion star, right? Large ones with 1,000 billion stars. Ours pretty big, maybe You could say 100 billion, I'd be fine with that, or 300 billion stars. So universe, superclusters, clusters of galaxies, our galaxy, our solar system, our planet, our life, maybe 3 billion heartbeats or seconds. In that context, though, we're going to take a look, again, not knowing. All right, let's take a look here. What we're going to look at is the night sky. And we're going to talk about that and think about this a little bit. Kind of cheating and looking ahead. Also looking back on what we've done. But you know that sky? Orion, the hunter. Betelgeuse. Oops. Orion's belt, Orion's sword, Orion's foot, Rigel. Arabic for foot. You know, they get all messed up in the translation. Betelgeuse or Betelgeuse. There's going to be a V over here, Taurus. I'll show you that in a second. Look at that triangle, the winter triangle. The brightest star in our sky, always except sun. Sirius, part of a dog. Procyon, part of a dog, which is 2 dots. I don't know, is it a hot dog? What is that? Gemini's up over here. This is all going to lead us into planets. But it's also going to be a nice review. Let's take a peek. All right, you've got this in your book. A little exercise, so I'm not going to do it all. Okay, remember, a little quick review. Remember this? Oh, yeah. Which way should we face if we want to watch planets or sun? Yeah, that's right. We want to face south. Okay, and things will rise and set, but the stars will stay together. Okay. East on my left. If I turn around, east will now be on my right, and I'll draw it like that. Okay, let's take a look here, as we will a lot, and let's take a look at that Orion region. Beautiful region. Out at night, out in winter, it's a good time. Use your phone app to find that out. Find out what's out when. And this is how, one way people marked time. Think about the Babylonians, that civilization that goes, how many thousands of years back? Check that out real quick. You can find out so much so fast. All right, here we are. This is my little sketch. That was a real picture. Now, here's Rigel, the foot. There's a star. It's a star. Again, we're cheating a little bit here because back in the day, you just see them dots of light. You don't know. You don't think they're the same as the sun. There's only one sun, right? But we're cheating a little bit. Stars. Okay. Some appearing brighter than others. Brighter being magnitude, apparent magnitude, or visual magnitude, or just sometimes magnitude, but still meaning apparent magnitude. If it's brighter, is the M bigger or smaller? Who's the brighter athlete? First place or second place? One's brighter than 2. One's brighter than 6. 0 is brighter than 1. Okay, then it got a little funny. Okay. So let's check these out a little bit. I'll show you how to do it. So we can talk about each star: Rigel, Betelgeuse, Aldebaran, Procyon, Sirius. Now you can group them. Again, remember, stories are all made up. So one group stories or patterns will be different than another pattern. This is often seen the shoulders, belt, feet, or knees. Sometimes it's drawn as knees. Draw it however you want. You know, sword, interesting stuff there. The V of Taurus, the bull, Orion, the hunter, hunting the bull. Little group here called Pleiades, Seven Sister, Subaru for unity in Japan, like the car, canoe for some Native Americans. Notice how this makes a nice triangle. You saw a better triangle out there. Really nice. Procyon, Canis, dog, minor, little. Seriously, hot dog, Chihuahua, what is that? Big dog here, Canis, dog, major, big. It looks something like this, really. It's kind of, and you wonder, like, if you could make anything, so it's not really a big dog, it's somebody's story, and it doesn't have to be. There's a tail, there's a back leg, here's a back, here's a front leg, here's a head. these two dots are not very bright, so the apparent magnitude is big or small. Not very bright, big M, right? So you gotta have a dark sky to see those. Remember that list, make sure you're reviewing that list. And what might we want to know? Might want to know a lot about it. Gemini, by the way, is up here, and we're gonna pull that in. We'll see Taurus over here. Oh, which way am I facing? I'll tell you, we're gonna be facing here south. So I'll throw south in. And if it's south, then what direction is this? Ah, eat sandwich. Right, so east, it's gonna rise up, right? The whole sky, the fixed stars will rise and then set over here in somewhere around the west, not directly west, somewhere around west, right? And the San Francisco Bay Area, you got across the bay is Mount Tamalpais, Mount Tam. So whatever, pick out your landmarks for wherever you are, and then you can get a sense, and the sky will go like that in one evening, right? And in a day, they're out there too. So if sun is out here, you're not gonna see this. And that's a cycle that we'll get to. For each star, you might wonder how bright it is. And again, with your naked eye, you could tell which ones are brighter. We saw the ones that we were looking at on that picture, those are bright ones, right? They appear bright. But does that mean that they're giving off more light than the other ones? The other ones could be farther away. The other ones could actually be giving off more light. As you get farther away, they appear dimmer. If they give off more light, they appear brighter. If they get closer, they appear brighter. So these are the factors. So you can see the color if you let your eyes darken that enough, or do an exposure, time exposure. We'd wonder, but we can't see the distance and the luminosity compared to sun. How many suns worth of light is it giving off? Half? 1/10? 10? 10 suns of lights. Can you imagine the sunburn there? All right, let's check this out. Now, how do I do this? I just get on here and I type something in. Rigel, distance, etc. So I'm just going to give you a little taste. So one thing that you will find is the apparent magnitude for Sirius. I'm going to put this in as, I'm going to put it in because it's easy to remember, -1.5. You might see -1.47 or 46, who cares? But that's the brightest star in our sky, ever, but again, it could be out during the day, so. Procyon, if you look it up, you just go Procyon, just go, put it, Procyon apparent magnitude, and then change the name of Procyon, put Sirius, just type over it, say Sirius. You get this, and different sources will give you different numbers. It depends on the data, because, depends on some factors, but we just want to think about this. So which one's brighter? Is this bright? Yeah, you just saw it. It's bright. That's nearly a 0. It's bright, right? But this is brighter because it's smaller. It's brighter, right? You can look up the colors. This one's kind of white. On the horizon, if it's out at night for you, look at Sirius on the horizon. You're going to see little diamond-like rainbow sparkles. Why is that? Good question. Distance. Which one do you think's closer? Would you guess? Would you bet? Would you bet $1,000? Okay. Could you know? For thousands of years, could you know? Could the court astronomer know? Could the tribe astronomer know? No. No way. But now we can look it up. Right? What do we find? We find the distance of Sirius is like 8.6 light years. Now let's think about some logic, and this is what you need to be able to do. And sometimes these things are funny, so then you have to dig deeper. So sometimes you'll look things up, and if you look deeper, there may be different measurements or some other factors, but get this idea. The distance for Procyon, now that's a close star. right? What's the closest star? How close? 4 light years, right? 4.2 light years, seen from the southern hemisphere. So that is a close star. 10 is close. 100 is close. Light years. This one's 11 light years. So they're close. That's why they're so bright. But how much light are they giving off? Which one would give off more light? Oops, sorry. Don't talk while you're writing your homework. Distance, 11 light years. I mean, light from that star, it's glowing, creating light, and that takes 11 years to get to your eye. Whatever you're seeing is an 11-year-old picture of that star. This is an 8.6-year-old picture of that star. Now, that'll change that quickly, but okay. So let me look it up. Luminosity. I'll just say luminosity of Procyon. So Procyon, here I am, Procyon luminosity. That's Procyon B. I don't want that. There we go. There's a Procyon B and a Procyon A. What does that mean? Oh, there's 2 stars there. A B and an A, Sirius too. So you see these funny things. So by exploring, you learn. That's kind of what science is. Procyon A is about 7. Remember that dot and circle? That means sun. Procyon A is giving off 7 times more light than sun. That's crazy. But it certainly doesn't look as bright as sun because it's farther away. Sun is 1 AU away. 1 light year is 63,000 AU, which is about 1,500 times farther, 1,500 times farther than Pluto on average. I'm just rounding off numbers. That's 1 light year. There's 11 of those. So yeah, it's gonna look dimmer than the sun does. But it's giving off that's a crazy. Are you kidding me? What if I look up Sirius? So I'm just gonna, here I am, I'm just gonna type it right in here, right? I already got luminosity there, so all I have to do is write this. Are you serious? Yes. Oh, there's an A and a B, huh? Sirius. 25.4, who cares? Does this make sense? It's closer and it's brighter. Oops. And it's giving off 25 times as much light. Let's see which way I want to do this as this. So why is it brighter with a smaller m? Because it's closer and it's giving off more light, making it, yay, the winner. That makes sense. It's got 2 things going for it. I'll let you do a lot of these other ones, but Betelgeuse is an interesting one. I'll just tell you, 0.42. Pause, what does that tell you? You know, it's about as bright as Procyon. The color, however, is going to be different. It's going to be kind of an orangish color. Color's going to look different. Go look. You can look it up too if you want, but sometimes you won't see it in the picture, but sometimes you will. What about the distance? Well, they look the same brightness, so maybe they're the same distance, but wait a minute. What if, since they're about the same paramagnitude, right, brightness, what if this was closer? Would it be giving off more or less light? If it's closer and look the same brightness, to look the same brightness and be closer, it'd have to be giving off, you got to get this, don't wait for me. Think it through, pause. Less light. If it's farther away and looks the same brightness, it's got to be giving off more light. Now, if you look, you get something like, I think, 642 light years. But be careful, if you really want to dig into it, there's a range. We're getting better data now, but it's a range, and so it's still far. It's far. So if this is true, then when you're looking at that, you're looking at an image that's 640. Go back in history and what was going on there around 1400. Right? That's when the light that is streaming in and finally gets to you, the message, the phone call, the mail, email, whatever, finally getting to you from there. So does that mean it's giving off more or less light? How many suns worth? And again, these measurements, it's a little bit tricky. So I'm just going to give it, and it actually is variable. It gets brighter and dimmer and brighter and dimmer. So this is a very interesting star being studied right now. It just had some interesting characteristics. So I'm going to give you a super rough, okay? 100 times, oh no, not 100. 100,000 suns of light. Sunburn. But it's far away. It's giving off a lot more light, but it's a lot farther away, so they look the same. Go through these. This is cool. This was cool. It's even farther away, like 800 and some light years. Check it out. That activity will really reinforce this. So so I encourage you to go through that. That reviews our what we can and can't see about stars. Remember that they move together. You can make whatever pattern you want. This if you will, this triangle here is called the winter triangle. It's not really called a constellation. We call it asterism. That's chapter 2. It's easy to see. It stands out. Orion's belt. But people did other things. I think there was some Native American tribe that did like a canoe here. You know, one's not right, one's not wrong. Everybody will make the dots the way this is, but people will connect them differently and tell different stories. Those are just the stories, right? Gemini, Gemini, we say often, but Gemini. It's just a story. Why? Because those two dots are kind of similar looking in brightness. And then you could do a stick figure, two stick figures, the twins. And then there's a story about them. The story is, they're brothers, but one was immortal, would never die. One was mortal and would die. And the one that was immortal found out the other one was going to die and said, well, I'll kill myself. I don't know how that works really, but it's a story. So, if you don't, it doesn't rule your life. It's just a story. It's just a pattern that people made up, and then the God said, "Okay, you don't kill yourself. We'll make you both immortal. Live in the heavens immortally." That's just the story. Something like that. I mean, I botched it a little bit, but you can look it up. There's other stories. Again, other cultures. It wasn't just the Greek, Mediterranean cultures too, right? So, Orion. Aldebaran, Taurus the bull, with horns that go way up here, right? Pleiades. Make up your own stories. They're interesting, like a kid's book or something like that. Tell a worldview, but that's it. We're going to go on. We're going to go on to planets, and we're going to leave that up because I'm going to tell you something about that.